Hi class, this is course 2, lesson 9, adding, subtracting, and multiplying fractions and talking about reciprocals, and also lesson 15, equivalent fractions and reducing. Okay, so we're going to do a whole section here about fractions for the next couple days, and it's not going to follow the book precisely. So be sure to write down any questions you have and then ask them in class or during homeroom or study hall or something. Okay, just make sure we get our questions addressed. So first thing we need to talk about is the simplest form. Simplest form is the form of a fraction when the GCF, and remember that's greatest common factor, of the numerator and the denominator is 1. And so what we're saying is that we're going to want to make sure that the only number that the numerator and the denominator have in common to multiply to get those numbers is 1. Okay, so here's an example. We're going to take the fraction 8/24. Okay, I look at 8 and I look at 24 and I think, well, boy, they're both even, right? So I could divide those both by 2, and that would equal 4/12. And then I need to look at this and say, oh, those are both even yet. So I know they both have a common factor of 2, and that would equal 2/6. And then I can keep going, divide that by 2, and that would equal 1/3. Now 1 and 3, 1 only has the factor 1, so I know that this is simplest form right here, 1/3. Now, one of the cool things we can do is we can look at this fraction, 2 2s. This is a form of 1, and I'm just going to draw this. You can, in your notebook, there, that's a 1. Same thing here. Ooh, that's a big, there we go. That's 1, and this one would be 1 as well. Okay, so we're going to pick values for 1 that we know are going to work. And we're going to divide, and that's not going to change the fraction. It's going to change what it looks like, but it doesn't change what it represents. Okay, so basically we're looking for factors that the two numbers have in common, and then we're dividing by that factor. Now we could have done looked at this and said, oh, well, I could divide by 8. Well, 2 times 2 times 2 is 8, and if we divided by 8/8, we would have got 1/3 right away. Okay, now equivalent fractions are two fractions that name the same amount. And that's what we did just up here, but you need to know that that's the definition of equivalent fractions. And it also comes from lesson 15, so you might want to star that or put that in the table of contents. Make sure that you have equivalent fractions written there so that when you're looking for them, you know where to find them. We just did one. 8/24 is the same thing as 1/3. So if we have an item or like a piece of not a piece of pizza, a whole pizza, if we cut it into 24 small pieces and then you take 8 of them, that's the same thing as if we cut it into 3 pieces that are all the same size and you take 1. It's the same amount, just looks different. Another one might be 4/8. That's the same thing as 1/2. Okay. If you have 4 out of 8, it's the same thing as having 1 out of 2. Okay. And these are found, in this case they were found by dividing, but we could work backwards. We could say if I had 4/5 of something, I could make 4/5 have a denominator of 10 by multiplying 5 by 2, and then I would multiply the 4 by 2 also and get 8/10. So 4/5 and 8/10 are equivalent fractions. They name the same amount, they just look different. Okay, what if we add and subtract fractions? To add and subtract fractions, they need to have the same denominator. Okay, so let's do a couple examples here. We're going to do one example where we have the fraction 1/8 and we're going to add to it 5/8. Okay, and that's going to equal something. But first I want to make sure that you understand that those denominators are the same. Then I can add. Okay, when you add, you only add the numerators. Okay, only add the numerators. So 5 plus 1 is 6. The denominator stays the same. I still have that many pieces, or I didn't change how many groups I had or how many slices of pizza were in the pizza pan. Now I need to look at this and simplify if I can. Okay, so are there factors in common, 6 and 8? Well, they're both even, so you know automatically you can divide both by 2. So if you're going to take 6, you're going to divide by 2 over 2, and remember that is our fraction that represents 1. Okay? 6 divided by 2 would be 3, and 8 divided by 2 would be 4. So when I add 1/8 plus 5/8, it's really 3/4. That is simplest form. Okay, we're going to do another example. We're going to subtract, and I have 13/16, and I'm going to subtract 9/16 from that. Same thing, our denominators have to be the same. So 13 minus 9 is 4. Leave the denominator alone. Now we need to simplify, and I know that 4 times 4 is 16, so I can divide both of these by 4. And again, that's my well-chosen one right here. Okay. So what is 4 divided by 4? That's 1, and 16 divided by 4 is 4, and that is in simplest form. You'll want to always put your answer in simplest form, unless it specifically tells you not to. Okay, but practice simplest form. Okay, so what happens if the denominators are different? Then you have to find the LCD. You remember what that stands for? That should be the least common denominator. Okay, so we need to find the least common denominator to make them the same. Let's do an example. Let's take 4/5 and add 2/3 to it. Okay, I have to know what size pieces that I have, so I need to get a common denominator. And the least common denominator is the same thing. You can multiply them together, but that's not going to guarantee that you get the least common denominator. What you can do is make a list. So count by 5s. 5, 10, 15, 20. Count by 3s. 3, 6, 9, 12, 15. When you get some overlap, when you have the same number appear, that's your least common denominator. Okay. So what do we do with that, right? So we know our LCD equals 15. What do we do with that? Well, we're going to take 4/5 and we're going to take 2/3, and I'm going to write them like this just so that I can see the process happen. I need to multiply each of these fractions by some number so that I get 15 in the denominator. Okay, so what number am I going to multiply by? I need a fancy number 1 fraction here, right? And I need one up here as well. How am I going to multiply? What do I multiply 5 by to get 15? Well, that should be a 3, and if the denominator in my 1 fraction is a 3, my numerator needs to be also. In the 2/3 fraction, what do I multiply 3 by to get 15? It would have to be a 5, and so my numerator needs to be 5. So I'm going to multiply 4/5 by 3/3 and 2/3 by 5/5. Okay? 5 times 3 we've already established is 15. 4 times 3 is 12. 3 times 5 is 15. 2 times 5 is 10. Okay, now I'm going to add these. And remember that when we add them, what do? Oh, whoops, you don't need that yet. Well, we will. When we add the numerators. 12 plus 10 is 22, and we keep the denominator. Okay. But now, there's where your note comes in. This is an improper fraction. The numerator is larger than the denominator. So what do? We are going to divide it. We have to divide it. So put the numerator in the box, put the denominator outside, and how many times will 15 go into 22? 1. 1 times 15 is 15, and subtract, and I get 7. Now this is not where we're going to use the remainder. No R remainder. Okay? Don't do it. This becomes the numerator, and the 15 becomes the denominator. Okay, and maybe right here isn't the best place to put those labels, but let's kind of kick this out over here, and we're going to put our whole number 1, and then we're going to put 7 out of 15. That's how many we had remaining. That's how you change an improper fraction into a mixed number. Now, how would you change this back from a mixed number to an improper fraction? Well, you multiply 15 times 1, and then add the numerator 7, and you get 22. Keep the denominator 15. Okay, and we'll go over that. We'll have a power-up that you have to do in the next couple days that you'll get to practice that skill on. Okay, otherwise that's all I have. I'll see you in class.